Hello all, welcome to today's series of webinar, and this is going to be a topic on advanced prompting and LLM techniques. So as we all know, prompt engineering is one of the most important thing when it comes to your LLM. So when I am supposed to bring in an important aspect of how we are going to get the appropriate outcome out of an LLM, and prompting is very important in that aspects. So in today's session, we are going to see how advanced prompting and LLM techniques can be used. As we are crystal here and most probably aware of the previous strategies which we are using in the prompting. So which was going to be few shot and chain of thoughts, and moreover, how we will be tuning this model and what are the techniques which are available in today's world. So right now you can see I'm making use of transformers and torch, and using my Google Colab, since we need close association with the GPU. I have already enabled the GPU instance. So right now we are using two libraries and the models. As we go, we will be changing the models now and then. So first, I'm making use of auto tokenizer and auto model for casual LLM. So we are also aware that auto models or auto ADA, auto ML. So all these play a major and crucial role. Like that, we do have a library which is taking auto tokenizer, which is used to create tokens, and auto model for casual LLM for generating our outcome for the LLM. As you can see, this is a generic model class that will be instantiated as of the model classes. Okay. So that is what we are going to use in today's session. Now here, right now, I'm using GPT Neo model. 1.3 billion parameters is what it has been trained on. Okay. You can use a premium model also, a premium model which requires API key like a Claude, okay, like a GPT-4 model or any other versions of the model. If you feel free, you can use those model. And first we are converting the tokens. So right now, after taking the model into consideration, I'm gathering the tokens which are present in the model. So which is going to be this many parameters which has been already trained. Now, using our casual LLM, we are going to load this tokenizer and we are seeing the configurations or vocabularies or some of the JSON intakes which are already present along with the model. So as you can see, this is nearly 5.31 gigs of information which is present inside this model. You don't have to worry because we already are using a free version of Google. So as you can see, this will not take much time. When you have enabled the GPU instance, all you have to go is go to this area, click on change runtime. Okay, if I do this, all these information will be gone. So I'm not making it. Now, coming to the aspect. So this model has been loaded successfully. Now, what is a zero shot? Okay, first of all, what is a zero shot is all about and how we are going to make use of this. It is going to perform a task without prior example. Okay, so here it does not have any information previously. It is more or like I'm asking something from a model, but it does not have a prior information on top of that model. Ideally, when we train our normal machine learning models, we will train them with what we expect as an input. So here in zero shot algorithm, we are not taking that expected aspect of the information to be provided upfront. So here you can see I'm giving a prompt. Okay, I'm making a prompt. So here the prompt is here. I want this to be translated from English to French. So when you're trying to learn especially this prompting techniques. First, you can try with this translation because one such use case of large language model, okay, more than summarization or generation of a text or creating a passage is more towards natural language processing, NLP, or natural language mining, you can tell. So here you can say, hello, how are you? Okay, this is going to be in English. Now, I want this sentence to be translated into another language. Now, as we have already told, a zero shot does not require, okay, the previous information or the previous state of information which is required for the input. So here, ideally, hello, how are you is not something which is to be stored in the memory of an LL. So now what we will do? We will take this information, we will feed this information onto our model which have been already loaded. Now this is the model, okay? GPT Neo 1.3 billion parameter model is the model which I have been loading. And now take the tokenizer, pass the prompt which you want to pass. Okay. Here I'm creating a tensor. This tensor is in PyTorch format. Now, with respect to outcome, this is the area when you're using a free model. Okay. This is an open source model which has its own set of limitations. You cannot expect too much of outcomes out of this. So what you can do with this, only this much of information we can expect. Okay, after giving multiple trials and attempts, I do used multiple models, open source model. Now here I'm taking the input. Okay, so here you can see we have not used any input, but I do have an ID which is also tagged along as an internal parameter for this input argument, a maximum length. Okay, so when you don't provide an appropriate maximum length, what happens? We will not receive an expected outcome. Okay, so here the maximum length we have chosen is 50. If I have chosen, okay, a maximum length of more than 100 or 150 or 200 something, then here, according to the input you have given, that many tokens it has to process, and ideally this model will result in error. So here we are limiting this maximum length. If you use a premium version of any of the models, you can easily cross this one. So here we have taken the written sentence as one and passing this information onto the decoder model, and it is going to produce the first set of information and it is keeping other set of informations which are extracted. This is more or like the verbo setting which we are doing in our normal machine learning algorithm. Okay, while we run the model, it is also showing some information related on cross validations or train and test score. So here I'm skipping that information and I'm generating the text. Now, what is hello, how are you in French? As you can see, okay, bonjour, comment, voici. So this is the translated version of the French term of hello, how are you, which is in English. So this is coming under zero shot algorithm, which does not require any pre-state to be fed into your model. Now moving ahead, we are crossing another set of technique, which is few shot prompting. Now, in few shot prompting, as the name suggests, here I gave one shot or zero shot, you can say. Okay, I have not given too much of information here. Now, as we move further, what happens? I'm giving too much of information. Okay, as you can see, the model also which I have used, okay, model also which I have used is differing. And you can also see one more important thing, the reason behind using natural language processing. Okay, Opus. We are using an Opus model. The reason is the content which I have given. Okay, the content which I have given is present in French. Okay, so which is why we are making use of the model Opus MT English to French. Okay, so here we are using Marianne MT model and Marianne tokenizer. So according to the model you choose, the tokenizer will also differ. As you can see, in the previous one, we have used GPT model and a different tokenizer called auto tokenizer. Now coming here, because of this French conversation, we are using Helensky NLP model and Opus model. Now, first, as usual, we will extract the tokenizer from the model. And I'm going to load the pre-trained model here. As you can see, the prompt is translate the following English sentence to French. Okay. What is that English sentence? Hello, how are you? Okay. This is the conversation. Good morning. Bonjour. Now, how is the weather? Okay. How is the weather today? If I pass this, I have to see the respected conversation corresponding to this. So if you observe how different this one and the previous one is. Here I just gave a hint. Okay, given a sentence, show me what is the translated sentence. So given a sentence, you can expect German, okay, Asian language, Japanese, or Chinese, Mandarin, okay. So Thai, any language you can expect, which does not require a prior knowledge. But here, I'm giving you what I want as an expectation. Okay, I want you to tell me how are you as expected like this. So I'm feeding, this is English and the corresponding conversation is a French conversation. Okay, this is an English, the corresponding conversation is a French conversation. So if I give you another set of English conversation, without me telling anything, it has to give me an output. Okay, here this is called few shot, feeding both the information and the information is also increased in input. Okay, so when I tried this with the previous model, I was not able to get an expected result. The reason is with free models, we can use a limited amount. Okay, so here I'm taking the input as usual. We are getting the tensors as PyTorch, padding, or truncation. Okay, if at all you know what is padding is all about. Okay, in order not to omit any sentence or in your convolution neural network, when you add padding, the edges of that images will be clearly coming into picture. So we are taking two features or two arguments which are very important, that is padding and truncation. Post that, I have increased the length. Remember, in the previous comment, we have discussed on 50. Okay, if I use the same model and I have given here 100, I might not expect or see the same result. So we have changed the model and the maximum length is 100. Okay, so as you can see, it is trying to tell the results. Okay, bonjour and bonjour is bonjour. Okay, this is the comment. You can see how it is trying to convert. Hello, how are you? Okay, hello, how are you? Bonjour, comment alias was. Then bonjour, comment sawa. This is already written. Then good morning. Good morning is bonjour. It is bonjour only. Then now translate how is the weather today. So it is also taking this into consideration and it is telling me comment wala method or hul. So this is the transformation which you are receiving because of few shot prompting. Okay. So the previous one is zero shot. The second one is few shot prompting. The third one is chain of thought prompt. So what is chain of thought prompting? Now here I'm using the same GPT model. Okay, I'm using the same GPT model. You can use any other model. Now what is chain of thought? So if I ask one question, that question can be a question which is expecting an outcome from the previous one. Okay. Let's say, for example, the discount of the product is going to be 5%. And if the marketing price of this product is 1000 rupees, give me the discounted price. That is the case. I'm expecting two input here. One is discounted product. Another one is the original price has to be done with calculation and I have to get the expected outcome. Now here you can see I'm using the same model. Okay, I'm not changing anything. I'm not changing any information. I'm using the same similar model. Now, I might have used the previous example, but for you to show or understand the process, here calculation is coming into picture. Okay, LLM are prone to hallucination. LLMs are prone to hallucination means not only they can hallucinate the information. Okay, if I say, for example, I gave a prompt in ChatGPT. Okay, I'm asking a question. So, what is the rate at which the stock market of a particular stock price is increasing? Is it good or bad? It will directly fetch the information. But when I say, I am asking if I stress some keywords, okay, tell me whether it is wrong or right. First, it will think from my perspective and it will give me sometimes a wrong information also. Now here, I'm adding the arithmetic operations. What is 100 plus 10? Okay. So you can see in normal or ideal scenario, 100 plus 10 will be 110. If I add on, keep on adding a complexity, what happens? LLM will struggle. Okay. So here you can see what is negative 0.0011 subtracted from this complicated scenario. Negative is here, negative is here. Okay. In both the scenario, how this LLM is trying to give me a result. Okay. Even we are using an attention mask here. Okay. Which is going to return me a result like this. Okay. You can see. So right now you have seen I have used this GPU for almost half an hour. Soon it got, okay, run out. So 110. What is 0.0011 negative 0.5? Okay, 0.4. And what is negative this one as this one? So this is more or like asking a question based on the previous question's outcome. The expected outcome should be coming based on the previous results. More or like you're writing a loop. One loop is acting as an outcome for another loop as an input. So in that way, if I give a prompt, it is called chain of thought prompt. Okay. Now, coming again, fine tuning. So in LLM techniques, more than prompting, what you can do, you can increase the fine tuning aspect. Okay. So when I say fine tuning aspects, here we are using a Distilbert model. Okay. A open source model, which does not require any sort of APIs or such thing. Even if you require an API, you can get it from a Hugging Face itself. All you have to do is create an account and be ready with the model to pull down from the repo. Now here, the Distilbert tokenizer, Distilbert sequence classification, trainer and training arguments. So this is the transformer library, or from transformers, we are taking all these models into consideration. As you can see, I have also pulled down the data set from Torch library. Okay. Now, in order to show how fine tuning is more or like a prediction aspect of an LLM, how it is going to help. Okay. If you have been a part of text mining, NLP, and GenAI, this is more or like, instead of using a traditional machine learning approach, we are making use of advanced model via a neural network LLM model. Okay. So here, a custom data set. So what this data set will do, it will take the text, it will take the labels. Of course, I need a tokenizer in order to know what is the content is all about. Okay. Here, pre-processing is converting your text into tokens. That is pre-processing. Now, creating the length and creating an item of to add the padding, truncation, everything. Of course, we need the tensors to be as PyTorch. So creating IDs for each and every tokenizer, we are creating an ID and we are also adding a attention mask and we are adding a label. Now, as you can see, what is the text which I'm supposed to give and what are the labels which I'm asking. Now, how I'm building a predictive model, that is what we are seeing here. Okay. After creating a user-defined function on a custom data set, you can see the input is this. What is the input? I love this. I hate this. This is amazing. This is terrible. Okay. Here, we are making use of sequence classification. Okay. We are making use of sequence classification aspect. Okay. Now, what is the sentiment related to this? Okay, sequence classification means I'm talking about sentiment. Now, what is the sentiment of this? It is a positive sentiment. Okay, so in this, I and this is more or like a stop word. Okay, love is a verb. It is a verb. So that is calculated as positive. In similar way, I hate this. Okay, you can say this is, and this one is a stop word. This is going to be one more time a verb. It is going to be a negative aspect. So amazing. Okay, amazing is an adjective. So it is going to be a positive word. Terrible. Okay, we use terrible in most critical scenarios, or most probably you can say it is not a positive scenario. Obviously, it is going to be negative. So this is my input and this is my label or the target, which is an output. Now, using my Distilbert model, okay, using my Distilbert model, what we can do here, okay, we are taking our Distilbert model and we are asking this text and labels to be classified onto this data set. Okay, it will take this data, it will try to bring you the clear-cut classification of this. Now, taking this information, providing that inside the training arguments and setting a small epoch. As my data is very small, which is almost 4 rows, you can tell, you can even increase this one. Even if you have CUDA installed in your local machine, you can still do that in a very effective manner with increased epochs. Now here I have only taken 3, okay, and all these are the aspects of training arguments. Here only the model will get trained, okay. Once I train the model, I'm going to evaluate the model based on this. Now, I'm giving I hate this. Okay. I'm giving an input which is I hate this. While I give the input, I'm also passing, okay, the pattern of the tensors, which is a PT. Okay, we have already taken padding and truncation. If you remember here, it is already done. So during the evaluation, if I ask this question, I hate this, the expected outcome, okay, we got as negative. Okay. So in this way, you can even fine tune the model, which can be used for the classification or sentiment analysis. Apart from this, okay, when I say advanced prompting, you do have the multimodal LLMs, okay, multimodal LLMs where you can combine different input types as you do in your real chat GPT. Okay. What I do in my chat GPT, I just copy paste an image. I ask that image some information gathering from that image. So that is a concept of multimodal aspect of LLM. Okay. So in this way, you can put an audio, you can expect an information, you can put audio, you can put an image, still you can receive an information. You can put a PDF, you can receive an information. Okay. Multiple PDFs you can load, you can get an expected outcome. So all these are concepts of advanced prompting technique. Hope you had a better idea on what is advanced prompting and LLM techniques. Thank you all.